Now we're going to put all this together and graph some classic polar curves. Now we're not going to graph all of them that are in your notes, but we're going to graph a few representative ones, and you'll see how to do this so you can do it on your homework. So you go through the steps we already went through, but first you'll know what it should look like from us learning about what kind. So we have 2 minus 2 sine theta. So that I know is a limison, and it is A over B would be 2 over 2. So it's equal to 1, so it's a cardioid. So I have a cardioid limison. That means I'm going to get a heart shape. Looking at symmetry, it's a sine, and I can tell it's going to be, I can test this, but I can tell, here's me testing it, the symmetry. I'm testing it for theta equals pi over 2 because that's usually what sine is. So sure enough, the symmetry goes straight down, theta equals pi over 2, so I'm over here. I calculate the max R values right here. So first I set R equal to sine theta equal to -1, and I get a 4, absolute value 4. And when I set it to a positive 1, I get 0. So I know 4 is going to be my maximum R value. I need to know what degree it will be, what angle it will be. So you set R equal to 4 and solve for sine, and I get sine theta is -1, and we know sine theta is -1 at 3 pi over 2. So I know at 3 pi over 2, I'm at my maximum 4. So if I really wanted to do that, I could put that point in right now. So I will. There is 4 at 3 pi over 2. All right, so here's how you write the maximum values. Absolute value of R equals 4 at theta equals 3 pi over 2. So make sure you do it in that manner. And then I go find my zeros. Here's me finding my zeros up here. I set 2 minus 2 sine theta equal to 0, solve for sine theta, and I get 1. So at pi over 2, I have a 0. So come back here, pi over 2, I have that point. And I know that it's symmetric, so those are on my axis, so I can't do any more points, but I know I only have to do this side because I can then get this side from symmetry. So here's me putting in my points. I'm actually starting at negative pi over 2. That was 4. That was your 3 pi over 2, right? I'm using the negatives of these points. Negative pi over 3 is about 3.7. So here's negative pi over 3. See my orange point appear on the graph. And then using symmetry on the left side, quadrant 3. Okay, negative pi over 6 is 3. So there on the graph, my orange point appears at negative pi over 6, and across the graph over at 7 pi over 6. And at 0, it was at 2. So I have a point at 2, and at pi, I have a point at 2. And so we know it's supposed to look like a heart. And there's my limison cardioid. So that was the first graphing example I was going to do. That was number 11. So the next graphing example I'm going to do is number 13. Jump into number 13. And I know these are a lot of work. That's why we're not doing all of them. So let's look at our example. We have 5 sine 3 theta. Okay, you should know that's a rose, an odd number of petals, so it's a 3-petal rose. Whoops, skipped ahead. 3-petal rose. All right, let's think of symmetry. We're going to try to see if it's symmetric to pi over 2. It is a sine. And since I know it's a direct sine, if I change both negative r and negative 3 theta, then I get the same thing. R equals 5 sine 3 theta. So here's me testing that and showing that. So it is symmetric to theta equals pi over 2. So I know I have symmetry going down the old y-axis, which is now r theta equals pi over 2. So we have symmetry at theta equals pi over 2. Finding the maximum r values, we set sine 3 theta equal to 1 and -1. So I get r equals 5 times -1, or negative absolute value of -5. And if I do it times +1, I get the absolute value of 5. So I know that r equals 5. The absolute value of r equals 5. So I have to find my angles. So 5 equals, set the equation equal to 5, and you get sine theta, 3 theta equals 1. Now, where does sine equal 1? It equals 1 at pi/2. But it's sine 3 theta, so I have to go all the way up to 6. So I have to go pi/2, and then another 2 pi, was 5 pi/2, 9 pi/2, and 11 pi/2. So I get, divide by 6 each of these by 6, and I get pi/6, 5 pi/6, 3 pi/2, and 11 pi/6. So those are the places it's going to be 5. So here's my maximum values of 5. It's quite often it's going to be 5. And last thing before I graph is the zeros. I set the equation equal to 0. I get sine 3 theta equals 0. So 3 theta is 0, or sine 3 theta it equals 0 at 0, pi, got to go all the way up to 6, 2 pi, 3 pi, 4 pi, 5 pi. 6 pi would be repeating. I go up to 6 pi, not at 6 pi. Have to divide each of those by 3, so 0 divided by 3 is 0, and then pi/3, 2 pi/3, 3 pi/3, which is pi, 4 pi/3, and 5 pi/3. So there's my zeros. Okay, so I've got everything I need to graph this. So symmetry to the theta equals pi/2, I need to use these points. Okay, so I'm going to start at negative pi/2. And when roses, I'll just tell you, sometimes rose petals are very small, and so you want to use the 12s too, probably. You've got your calculator anyway. That way, a lot of times the petals are narrow, and if you don't use pi/12, it's hard to see the graph. So I started it at negative pi/2, and that was one of my maximum values. So at negative pi/2, it's 5. So I have a point right there, right on the axis. Okay, so I went to negative 5 pi/12, which is this angle right here, and that came out to be 3.5. So a point there, and its symmetry would give me a point there. Going to negative pi/3, I'm already to 0, so that means there's a petal. Got that first petal. Now, making my way around, I have to go to negative pi/4, which is this point right here. Negative pi/4 gave me a negative 3.5, so I'm backing up. Here I am backing up to this point right here. Okay, so I'm going to erase the orange mark and then put the point there. Symmetry going across would make another one there. Okay, so let me put those 2 points in. Now, pi/6, this is negative pi/6 right here, gets a negative 5. So that's way over here, backwards, right? And then symmetry would put it over here at pi/6. And then negative pi/12 here, going backwards would give me another negative 3.5 here, and symmetry gives me 1 at pi/12. And then at 0, I'm back down to 0. So I know I have 2 more petals, there and there. Now, if I go to pi/12, I'm repeating. So I'm done. And that is the rose.